All right. Okay, so let me do this example. So for this one, okay, again, we want to add. Now the first denominator is factored already, right? 2x plus 1 is irreducible. Now, 4x squared minus 1, you can factor that. In fact, it's a difference of two squares. 4 we know is a square. So it is actually a difference of two squares. Namely, it's 2 times x squared minus 1 squared. So we can factor it like so. Again, it's just a difference of two squares. That's all we're doing here. It's kind of like what we saw before with x squared minus 9, what do we see? 4 squared, x squared minus 16. It's the same idea. Except here we have a coefficient that's also a perfect square. No big deal. So when we factor this, we get this thing here. Okay. So we have this. And this is again, this is already factored, as we said. So again, we want to get the LCD. So for the denominator, okay, let's get the factors. We have 2 times x minus 1, that's a factor. 2 times x plus 1, that's another factor, as we can see. But notice here notice here that the exponents of 2x plus 1, we have 1, we have 2. We need the biggest or the greatest exponent, right? The biggest exponent. And which one is that? That's going to be 2. I mean, 1's an exponent, 2's a bigger one, we take 2. 2x minus 1, right? The only exponent of 2x minus 1 is just 1, so we just take that. So what's the LCD? 2x plus 1 squared times 2x minus 1. To the first, but again, if the exponent's 1, we don't write it. So together then, so we get this, is the LCD. Now, so we need the denominator, right? We need that to be the LCD. Okay, that's no big deal. Well, we're adding these. So for the first one, 2x plus 1 squared, right? We're missing 2x minus 1. Right? If we multiply the bottom here by 2x minus 1, then this denominator will, this denominator here will become the LCD. And that's what we do. But whatever you do to the bottom, you must do to the top. Got to keep it algebraically equivalent. Okay. Same thing over here, right? I mean, it looks like we have the LCD, but actually we don't. We're missing a 2x plus 1 because we need 2x plus 1 squared. No big deal. We just multiply the bottom by it, but we also multiply the top by it, as you can see. So now the denominators both equal the LCD. And we have these new numerators, so to say. That's cool. Okay. Now, once we have that, right, what we do next is we have to multiply, right? As you can see, we're going to multiply. We have 6x squared minus 3x plus 2x minus 1. Okay. From here, we're going to get 2x squared plus x plus 6x plus 3. That's all over here, right? All over here. Then combining like terms, we get this. See? And say, okay, so now what do we do? Well, we want to know if this is simplified, right? You could just dive right in and try factoring the numerator. You could. Now, what I wanted to do is just factor. Let's say I want to try the factor theorem. I want to use that. But remember, to use it, you need x minus something, not 2x minus or plus something. Okay, well, let's take out a 2. Let's take out a common factor of 2. In other words, from the bottom, I'm going to factor it as 2 times x plus a half. Here, we have 2 times x minus a half. And from here, so that's what we're doing for the bottom. Notice also on the top, we can factor out 2. And that's what I'm doing. I'm just trying to make it easier. And once we plug that in, so again, from the top, I factored out 2. I want to use the factor theorem. So from the bottom, I'm taking out 2 as well, as you can see. Because I want to see if it's simplified or not. Okay. Well, let's see. So these two, okay, so once we do that, right? Yeah, let me just get rid of that. That's going to make it a little bit easier. Okay. So once we do that, right, you can see, I guess by the red marks that were there, this 2 will cancel with this 2. This one is all being squared, so this 2, when you bring it out, becomes 4, and we're left with this. Okay. Now, from here, right, we want to try the factor theorem. So we want to know, is a half or negative a half a factor of this? That's what we want to know. And by doing this calculation, it's not. Right? We want to know, is x plus a half a factor of this, or is x minus half a factor of this? Well, let's see. We plug in a half, and we want to know, do we get 0? We don't. If we plug in negative a half, we don't get 0. So by the factor theorem, these are not factors. So it is simplified. So again, it's just another example with the factor theorem. That's all we're doing. I mean, you could try factoring the numerator if you wanted to, although it turns out I think it's not, you can't factor it. So that's what we get here. Okay. Are there any questions on this? Any questions at all? Okay, well, let's do another one then, okay? Oh, no, actually, this one I want everyone to try. You know, so take about 5 minutes and try, and well, let's see, we're low on, you know, start working on it for like 3 minutes, then we'll do it together, okay? I just want everyone to, like, you know, work a bit.